Okay. So we're going to start off with number 5. Consider a protein with a single point mutation that causes the protein to denature, unfold at a lower temperature than the wild type. The equilibrium is defined as KEQ equals to unfolded protein over folded native protein. The KEQ of the protein at different temperatures was obtained from an experiment, and the values are provided in the table below. So this is a table. Using Excel, create a Van Hoff plot. Include a table showing any results from calculations, a trend line, and an equation of best fit. So I have drawn my graph out on Excel. You can see that. This graph. And so we use this first table to calculate the KEQ, the 1 over T and the ln KEQ using this from the previous table. And so for B, the question is, use the information to determine change of H and change of S. Use the equation given in the graph. So the equation that we got in the graph was y equals to negative 13,978x plus 47.042. And so that's the equation we use here. So we're going to do ln KEQ equals to negative change of H over R times 1 over T plus change of S over R. So this is y equals to m, which is this change H over R, and then x is 1 over T, and B is change S over R, which is entropy. And so the R constant is equal to 0.008. And so you basically have to do, this is from the constant 8.314, you just have to convert it to 0.008. And so you do change of H, which is the enthalpy, equals to negative times negative 13,978. So remember, you have to always use a negative slope. And then multiply by 0.008, and it equals to 111.824 kilojoules per mole. And then for entropy, it equals to 47.042 times 0.008 equals to 0.376336 kilojoules per mole. And then for 5C, what is change of G at 20 degrees Celsius? What other information can you obtain at this temperature? Explain. So 20 degrees Celsius plus 273 K, we have to convert the 20 degrees into kelvins, which is 293 K. And so it's going to be change of H minus T change of S equals to change of G. So you do 111.824, which we got from 5B, minus 293 times 0.376336, which we got from 5B also, and it equals to 1.558 kilojoules per mole. So now you can see that the reaction is not spontaneous at this temperature, since the change of G, which is the free energy, is positive. So this is positive. So if it was negative, it would be spontaneous. Okay. Moving on. So for 5D, what is change of G at 31 degrees Celsius if this reaction driven by enthalpy, entropy, or both at this temperature? So I use change of H minus T times change of S equals to change of G. So it's going to be 31 degrees Celsius, and you're going to convert that into kelvins, by adding 273 K, which equals to 304 K. So then you do 111.824, which you got from the previous problem, minus 304 times 0.376336, which equals to negative 2.582 kilojoules per mole. So this reaction is favorable because the change of G here is negative, and the reaction is driven by entropy because change of S was a positive leading reaction to be spontaneous. So whenever change of S is positive, the entropy, change of G will be negative. So when change of S is positive, there's going to be more disorder. So that's going to lead to more spontaneity. Does that make sense? Okay. So for 6, assume you are analyzing a reaction with KEQ equals to 7.94 times 10 to the 14th. What is change of G for this reaction? So change of G, we're going to use that equation, equals to negative RT ln KEQ. So that equals to negative 8.314 times 298K times ln of 7.94 times 10 to the 14th, which equals to negative 85,000 joules per mole. And then you can convert that to kilojoules per mole. So for 6b, what is change of G for this reaction? So we're going to do KEQ equals to KEQ over 10 to the negative 7. And it's going to be, the KEQ is going to be 7.94 times 10 to the 14th over 10 to the negative 7th, which is going to make our final KEQ equal to 7.94 times 10 to the 21st power. And then for change of G, the free energy, we're going to make it equal to negative RT ln KEQ. And it's going to be equal to negative 8.314 times 298 times ln of 7.94 times 10 to the 21st power. And that gives you this, which is negative 125 kilojoules per mole. Okay.
Excuse me. Why did you divide it by 10 to the negative 7?
Because, so KEQ, the equilibrium, so wait, let me see, sorry. 10 to the 14th.
Is it like a constant?
No, okay. Okay, so it's because this, the 10 of negative 7 is, can I get back to you on that? I'm so sorry. Okay.
I mean, it's okay. I'm just looking at text.
Sorry, I'm like trying to rush because like we're really behind. Okay. So for C, in which direction will this reaction proceed under standard biochemical conditions at a neutral pH? Justify your answer. So because change of G is less than 0 and KQ is greater than 1, the reaction will proceed in forward direction under standard biochemical conditions at neutral pH. So for 6C, what is change of G at 20 degrees Celsius? What other information can you obtain at this temperature? Explain. 20 degrees Celsius plus 273 K equals to 293 K. So change of H minus T times change of S equals to change of G. And
is this 5 or 6?
this is 6.
Thank you.
Okay, so what we're going to do is change of H minus T times change of S equals to change of G. So that's 111.824 minus 293 times 0.376336 equals to 1.558 kilojoules per mole. So as I said before, if it's positive, it's going to be non-spontaneous. So this one, kind of same for this. So you use this equation, change of H minus T times change of S equals to change of G. So 31 degrees Celsius plus 273 K equals to 304 K. So you do 111.824 minus 304 times 0.376336, which equals to negative 2.582 kilojoules per mole. So this means since it's negative, the reaction is going to be favorable. And the entropy is also going to be positive, which you can see here. So that means that it's spontaneous. Okay. Moving on to D and E. Okay. In what values of Q the reaction quotient would make change of G greater than 0, and what values of Q would make change of G less than 0? So if Q is less than KQ, it would make change of G greater than 0. And conversely, if Q is greater than KQ, then that would make change of G less than 0. So this is another graph one. So using Excel, plot change of G versus the ln Q at 100-fold increments over a 10 squared range. Example, one order of magnitude starting with a ratio that is 1 over 100 of the calculated KEQ value. Label your axis and include a linear trend line. What do you notice about the incremental change in change of G for a 10-fold change in Q? So this is like the stuff that they gave me. And then this is my graph, 6B. I want to see. So since the slope is constant, you see here, so there's not going to really be a change because the slope is constant here. It's going linearly. Okay. Okay, question 7. A UT Dallas biochemist has successfully sequenced a protein using mass spectrometry that is critical to the onset of lung cancer. A portion of its sequence is as follows. So cysteine, glycine, arginine, alanine, aspartic acid, threonine, and leucine. So you guys have to make sure that you memorize your amino acids, the 20 amino acids, memorize the 3 words and the little, the first words of them, as well as their structures. So write out single letter sequence of the peptide. So cysteine is going to be C, glycine is going to be G, arginine is going to be R, alanine is going to be A, aspartic acid is going to be D, threonine is going to be T, and leucine is going to be L. And then for 7B, this looks really like confusing. If you guys want, like I can make a video. Would that work? Of how to make the structure and stuff. Okay. I'll do that. Okay. And so according to this structure, so we have to use the side chains, the pKa's of that, which is cysteine and aspartate in our thing. So for aspartic acid, which is here, it's going to be negative. So this is aspartic acid, but it's going to be negative. The H is going to be gone. So we're going to do 8.33 plus 3.86 divided by 2, which makes the pi equals to 6.10. And so C is what is the sequence's overall charge at physiological pH, knowing this is a sequence acidic or basic. So at pH of 7.4, the overall charge is 0. To determine acidity or basicity, calculate the isoelectric point, which is 6.10. And since 6.10 is less than 7, the sequence is going to be acidic. So remember, like if the pH is less than 7, then it's going to be acidic. And if it's greater than 7, then it's going to be basic. Okay. And then for pi, if it's less than the given pH, then it's going to be acidic. And if the pi is greater than the given pH, it's going to be basic. So for 7D, classify each amino acid in the sequence by polarity and charge. So cysteine is going to be polar and uncharged. Glycine is going to be hydrophobic, nonpolar, and uncharged. Arginine is going to be basic, polar, and positively charged. And then alanine is going to be hydrophobic, nonpolar, and uncharged. Aspartic acid is going to be acidic, polar, and negatively charged. And then threonine is polar and uncharged, and leucine is hydrophobic, which is nonpolar and uncharged. So just make sure to like memorize not only the amino acids, but their properties. For example, like is it polar, hydrophobic, hydrophilic, aromatic, and stuff. Okay, last problem. So question 8. The following proteins represent a wide range of molecular weights and isoelectric points. So MR is the molecular weight of a single protein chain. So protein 1 is MR 22 Kd, and the pi is 3.85 dimer. The protein 2, MR, the molecular weight is 34 Kd, and the pi is 4.75. And then for protein 3, the molecular weight is 73 Kd, and the pi is 6.58. And then for protein 4, the molecular weight is 38 Kd, and the pi is 5.77. So which protein is the most basic? Explain your answer. So protein 3 will be the most basic as it has the highest pi. And so if there's a high pi, the protonation will be more likely to occur, and that will cause it to be more basic. Okay. And then for B, which protein will be the furthest from the top of an SDS page? Explain your answer. So protein 1, as it has the smallest molecular weight, so here it has the smallest molecular weight compared to the other ones of the single chain, and the SDS page is a denaturing gel, so peptides will migrate as single chains. Okay. And then so 8C, in what order will these proteins elute from an anion exchanger at pH 3.5? So it's going to be 3, 4, 2, 1. And this is because all proteins will bind to anion exchangers, since for all proteins, the pI will be greater than pH. The most positive proteins will be eluted first. So the higher the pI, the more positively charged the protein will be, and more likely it will be to be protonated. So in this case, we can see that protein 3's pI is 6.58, so it's the greatest, and then protein 4's pI is the second greatest, protein 2's pI is the third greatest, and then protein 1's pI is the last. Okay. So in what order will these proteins salt out from a pH 7 solution by the dropwise addition of NaCl? Explain your answer. So it's going to be the same, 3, 4, 2, 1. The ones with pI closest to 7 will salt out first. I finished so fast. Okay, I'll like explain things to you guys. Do you guys want me to show you the papers again, the problems, and then like just kind of go over them, or just like wait for you to write them down, or whatever matters for you? Because I know I went really fast. I'm scared I wasn't gonna finish. Do you guys have any opinions?
Finish by 3:15.
Yeah, I know. I was so scared. I was like, I'm not gonna finish. And 4 problems. Okay. Okay. I'll answer your question too. I'll look at the problem right now. So, does anyone online have any questions? You guys can type them out now. Or you're good to go if you want. And you can email me your questions. Yes, this recording will be up for everyone later. I'll post this in announcements. And if you guys please have any questions, please let me know and email me, because I can like explain it better through email. Yes?
When we do this for our problem set, we have to include our Excel in the when we turn it in, right?
Yes. You can ask me if you want, like, email me and stuff, but when you're making the graph too, I can help you out with that.
Okay.
Yeah, no problem. And then are you guys started on the problem set yet? Or?
Yeah.
I did some like over the weekend.
Okay.
Kind of hard.
Yeah, don't try to cram it in, because that's going to be really hard.
So is your test gonna look like these questions?
No, these problem set questions are like harder compared to the test. So like the test is mostly multiple choice. So I would recommend you guys to like study off the slide, the practice problems, and basically the practice problems meaning like the ones that they give you on the slides, and basically the textbook. Yeah.
Are there like old exams or something somewhere?
Yeah, I can send them to you.
Okay, thank you so much.
Yeah, no problem. I'll just send it in the group me or something. Yeah, I'll do that. I did not know I went that fast. Okay. And now let me look at the problem. Does anyone online have any questions in regards to the problems I did? I'll send you the one with the amino acid structures joined by peptide. I'll make another video for you guys so I can explain it more in detail. Yes, it was. I asked some students and they said that they saw it, so it's in the chat function. But if you guys want, I can post it in the announcement as well. Let me stop the recording.